In this video, we're going to talk about factoring quadratic trinomials. And we talked about this in another video using the guess and check method, and what we found was that sometimes it takes a long time to do the guess and check method when there are multiple numbers that multiply to be any one of the numbers in the trinomial. So I want to show you a different method. It is called factor by grouping, and we can organize our work for factor by grouping in one of two ways. So I'm going to show you this in one of two ways. Either way, it is factor by grouping, just organized a little differently. In order to do factor by grouping, the first thing that we do is we have to create a product sum, and I use an X to organize this, but you don't need to. So product meaning multiply, sum meaning add. So we want two things that multiply to be whatever our A times C is. So A times C goes up here, and they want to add to be B. So here's my B, here's my A, and my C. So in this product sum puzzle, A times C, 2 times negative 9 would be a negative 18, and my B term is a positive 3. So I want to find out what two numbers multiply to be negative 18 and add to be 3, or two numbers whose product is negative 18 and whose sum is 3. So let's go through this. If I'm multiplying to be negative, I know that one of the numbers has to be negative and one has to be positive. So now let's think through everything that multiplies to be 18. Well, we have, we have 1 times 18 is 18, 2 times 9, 3 times 6, and I think that's all of them. All right, so now we want all of these multiply to be 18. We want them to multiply to be negative 18. And so one of these has to be negative and one has to be positive. So let's make all of these negative. Either all of those could be negative and all of those are positive, or it could be the opposite way. You could have it where these are positive and these are negative. So let's think through which makes sense. We don't have to test all of these, because let's look. We want to add to be a positive 3. Well, if you're adding a positive number and a negative number, the only way the sum will be positive is if the bigger number is positive. So I don't even need to worry about these being negative, because 1 plus negative 18 would be a negative number. 2 and negative 9 add to be negative, and so on. So when we test these, because we're going to add to be positive, we know the smaller number has to be the negative one, and the bigger number has to be positive. And so now we want to see which of these add to be 3. So when I add negative 1 and 18, I get a positive 17. That's not what I want. When I add negative 2 and 9, I get a positive 7. That's not the number I want. Negative 3 plus 6 is equal to 3. That is the number I want. So the two numbers whose product is negative 18 and whose sum is 3 is negative 3 and a positive 6. And it doesn't matter which side you write this on. Again, that's just a way for me to organize my work. Okay, so we got those two numbers. That's the first part in factor by grouping. The next part, you can either write using a box or out in a row. I'm going to do the first using a box because a lot of students like that, but then I'll show you how to write this out just in a row. In order to do the box, what we do is we have the first term goes in the first spot in the box. So this is going to be a 2n squared, and the last term goes in the last spot in the box, so that is a negative 9. And then the reason that we have this negative 3 and the 6 is to put in the other two spots, and the reason why is that those two terms are going to add to be 3n. So I'm going to put the negative 3 and the 6 in here. But I'm not just going to put negative 3 and 6, because these two add to be b, which was up here, which that's really 3n. So this will be negative 3n and positive 6n. So you got to throw the n in there with it. So we've set up the box, and now we factor. And the first step is I'm going to ignore that bottom row, and I want to factor out the greatest common factor of these two terms, 2n squared and 6n. Well, the greatest common factor of 2 and 6 is 2. 2 is the largest number that is a factor of these two numbers. And then n squared and n, the common factor is an n. So now I'm looking, 2n times what is 2n squared? Well, 2n times n is 2n squared. And 2n times what is 6n? Well, that would be a positive 3. So now I look down here. What is the common factor of negative 3n and negative 9? Well, the common factor would be 3, except that the leading coefficient here is negative, so I'm going to factor out a negative 3. And now I got to double check to make sure that these all multiply out correctly. So negative 3 times n is a negative 3n. Negative 3 times 3 is a negative 9. So these would all multiply out correctly. So these guys over here become my factors. 2n minus 3 times n plus 3. Here is the factored form. And so for those of you that like to use the area model when you are multiplying binomials, this might be a nice way to organize this when you are factoring. And I'll show you why. So we can check to make sure this worked. If I were to ask you to multiply these two binomials, some of us would choose to draw a box to represent the area of a rectangle and say 2n minus 3. Well, actually, let's orient it the same way we did. Let's do the 2n minus 3 and then the n plus 3. And we'll multiply out. 2n times n is 2n squared. 2n times 3 is plus 6n. Negative 3 times n is a negative 3n. Negative 3 times positive 3 is a negative 9. And we said to find the total area, we would add up all of these terms, combine like terms here, and our final answer would be 2n squared plus 3n minus 9. Let me scooch down to see that. So that would be if we multiplied it out, which was the original problem we had here. So we can see it's working in the opposite direction. There you go. All right, so this is factor by grouping using a box to organize our work. That's one way. I want to show you another way to organize this. So I'm going to erase our checking of our work. Start back here. If you do it the other way, we're still going to use our product sum. So we want two things that multiply to be negative 18 and added to be 3. And those two numbers were negative 3 and 6. Excuse me, but this time, when we had our 2n squared plus 3n minus 9, what we're going to do is write these in a row. And so we just take that 2n squared, and we're going to still have that out front. That negative 9 is going to be at the very end, but instead of 3n, I want to break that apart. Some people will call this decomposition. We're going to decompose that 3n into these two terms, the negative 3n and a positive, well, I'm going to write this in a different order just to show you so it looks exactly like the other one, minus 3n. Okay? Erase that. Write that over here a little bit closer. Okay, there we go. So I'm decomposing this, and realize these two just add to be that. So these are equivalent expressions. They're just written in different forms. This one is decomposed a little bit. All right, so now what we do is we group these first two and these last two, and we'll put a little plus sign in between so that we know we're adding them and not multiplying. So we're going to group the first two terms together, the last two terms, and then we're going to factor out the common factor in each of these binomials. So in this binomial, the greatest common factor would be 2n. So I write a 2n. And 2n times 1n is 2n squared. 2n times a positive 3 gives me 6n. Over here, the greatest common factor, some people would say 3, but because the leading coefficient is a negative, we're going to factor out a negative 3. Negative 3 times n is negative 3n. Negative 3 times a positive 3 is a negative 9. So I've still factored out the GCF of each term, just like I did over here on this step. Now, what I recognize is that this group and this group have something in common. Well, what do they have in common? They have this n plus 3. So what I'm going to do is I'm going to take that n plus 3 out, and in parentheses, I'm going to put whatever is left over. So whatever is left over, let me get a blue marker here. If I take out n plus 3 from this group, I'm just left with this 2n. And if I take out the n plus 3 from this group, I'm just left with the negative 3. And so here is our final answer. We get the same thing in the parentheses there, so we can factor that out. And you'll notice we get the same thing no matter what. Now these are written in two different orders, but we know that the commutative property of multiplication says it doesn't matter what order we multiply in, and so we can use either one. These are equivalent expressions. So this would be factor by grouping written in a line. So if you like the distributive property or FOIL, this might be some way that you want to organize your work. If you liked using the area model or the box, you might want to organize your work this way. Either way, we get the same answer. And that is factor by grouping or factoring using decomposition.